Hi guys, I know that you had difficulties with this exercise. You have sent me many and I started for you. Now I took an exercise, some of your classmates send it to me. Maybe it's the lucky one who's going to see it. I'm going to start from the reactions. You see, I have a support A and B, and I have these three forces, 30 going up at C, 40 going in this direction at F, and at D, 20 going down. When you find the reaction, you consider this as a whole body. You understand what I mean? So consider if it is a number full, forget about what is inside. There are beams inside. Because we're finding first the reaction at the external supports. The forces T1, T2, T3 and change, what I find are the forces that are internal forces. They're always the same. They're in equilibrium. So at the beginning, we find the reaction of the external supports. You see, I have these reactions at B, so I have a horizontal reaction XB, and I have a vertical reaction. I'm not going to think what direction is the reaction. If I'm wrong, the result is going to show it. I'm just going to put it this way, YB, and this is at A, I have a vertical reaction, YA. By the sum of the forces in the axle X equals 0, guys, sum of forces in the axle X equals 0. What do I have in axle X? I have only XB and 40. In order that this sum is 0, this has to be equal. So right away, XB equals 40. That's it. Now, let's take, for example, sum of the moments about point B. Sum of the moments about point B equals 0. Let's start with the beginning. What I have about point B. Now I can see right away that YA is wrong. YA minus, how much is the distance? 4 plus 4, 8. You see, it's rotated this way. Distance is perpendicular from the point to the force, is 8. So I have minus YA times 8. 30 rotates again minus 30 times 4. The force 20 rotates again clockwise. So this is the point B. Minus 20 times 4. And this is the force 40 rotating again. Minus 40 times this distance is 3 equals 0. So you see, I have only negative numbers. Minus, cannot be 0. Some of them is positive, so this sign is wrong. So to make it easier, it's very easy, because if I can divide everything by 8, 8 minus 8 divided by 8 is 0. This is 2, and this is 15, and this is 10, and this is 5. So 15, 5 times 3 is 15. So 15, 15, 10 is 40. So YA is 40. The reaction YA is 40. Only what I have, I'm going to write here, YA equal minus 40. I did it fast, kilonewton, but you can check it. And it means that I'm going to change the direction here. It's going to be 40, but going down. So now YB, if I see all the sum of the forces in the axle vertical equals 0, I have 20 plus 40, which is 60. I have 30. What is left for YB? For YB is left 30. So by sum of the forces in the axle vertical. Of course, the safest way to find the reaction is now to take the sum of the moments about the point B. So point A, sorry. Sum of the moments about point A equals 0. So I'm just going to try. Let's suppose that I don't know the reaction. I have YB times 8, because this distance is 8. I have plus 30 times 4, because this rotates this way. Now this force 20 rotates on the other side, so it's minus 20, and this times 12. So this is big. And the force 40, the distance is the same, 3. Minus 40, the distance is the same, you see, 3. Because we said, remember, we said, if the force is parallel with the segment, the moment is always the same. The distance is always the same. This has to be equal to 0. So now I can simplify again. Of 8 divided by 8 is 0. This is going to be 15. And this is 12 divided by 4 is 3. So this is 30. Because it's 240 divided by 8 is, and this I have here minus 15. So I'm going to have 15 and 15 in neutralize, YB equal 30. So this is the result. We find the reaction wrong, everything is going to go wrong. I'm going to pause it, and now let's find the forces. So now we have the reaction, let's find the forces in the system. Where can I start? I can start from A. I cannot start from E because I have 1, 2, 3, 4 unknowns. I cannot start from C because I have 3 unknowns. I cannot start from B because I have 4 unknowns. I cannot start from F because I have 3 unknowns. I can start from D. So I can start either from D or from A. Both of them, you see, A and D are symmetrical, and if I call this angle alpha, guys, you see, sinus alpha is 3 over 5, is 0.6, and cosinus alpha is 4 over 5, is 0.8. That's it. Now let's start the equilibrium of the node A. So this is the node A. And what I have in A? I have the force that I know. This is 40. I'm not going to put the units, not too complicated. And I have this force which I don't know. I'm going to call it T1. So this is number 1. And this one, I'm going to call it T2. This is number 2. I bought different colors, but they look the same. I left my bag at Hamburg. The stolen property that I stole from George Brown, all those markers, they are in my desk at Hamburg. And this angle is alpha. Look now, if I take the sum of the forces in the axial vertical equals 0, what I have in axial vertical? I have T1 sinus alpha, because minus 40 equals 0. Or I'm going to have T1 equal 40 over sinus alpha, or 40. How much is sinus alpha? Is 3 over 5. So it's 40 over 5, 40 times 5, 200 divided by 3. So it's quite big, it's 660. So it's 200 divided by 3, not too bad. And this is 66.667 kilonewtons. This is T1. This is T1. Now, if I take the sum of the forces in the axial x equals 0, here, what I have? T1 cosinus alpha minus T2 equals 0. You see, T1 cosinus alpha now, because I have the horizontal projection, minus T2 equals 0. From this one, T2 equal T1 cosinus alpha, or T1 is this one, 40 times 5 over 3, and cosinus alpha is 4 over 5. So I have 160 over 3, which is 53.333. That's what I found. Now, when you go to the node C, it's very easy. You know why? Because if this force is T2, I'm going to, you know that I don't like to make a mess on the board, but here I have no choice. I'm going to draw here the point C. You see what I have a point C? I have this force 30, and I have this force unknown T3. And I have now this force, if T2 is going in the nodes, on the other direction, T2, we found T2, 53, 333. And this is the unknown, let's call it 6. 1, 2, 3, 4, 5, 6. Let's call it T6. Do I need to write the equations here? Look here. How much is going to be T3? 30. How much is going to be T6? 53.3. A combination like this, you are going to have in every of your exercise. Look at the node B. The same thing. The same thing. After I find this force, here I have intersection of forces, so it's going to be quite easy. That's the way you find the forces. I hope it's clear. I know that I'm talking very fast, but that's the way, because I want to have I have limited space of the videos that I can put. And if you have any question, please email me. Thank you.